So this section we will talk about the arc length. First, let me introduce some special curves called parametric curves. So normal curves are like defined by y equal to x squared, y equal to sine x, or sometimes x equal to y squared, x equal to y squared plus 5. But sometimes we are not able to find the curves defined in that way. Instead, they are defined like this in a parametric curve. Like x is equal to a parameter t, a function of that, and y equal to some t in another function. And we do know that there are some relationship between x and y, because for this example, like if you pick t equal to 0, then you plug inside, you find x equal to 0 and y equal to 1. So 0, 1, you can get a point on the xy plane here. So when t equal to 1 and you plug inside, you get x equal to -1 and y equal to 2. So -1, 2 is here. And similarly, you can pick other points like t equal to 2, you get 0, 3, t equal to 3, you get 3, 4, and you can pick t equal to -1, that is 3, 0, or many other points. Okay. So if you connect these points, you'll find they are all on this curve. Okay. And in fact, for this specific parametric curve, we are able to find the relationship between x and y directly because y is defined by a linear function of t. So you can solve t by y because t is just y minus 1, right? Then you plug into back here, you know, x equal to t squared minus 2t. So t is equal to y minus 1, y minus 1. So you get x equal to this. And if you simplify it, you get x is in fact y squared minus 4y plus 3. So this is a curve of y squared minus 4y plus 3 for x equal to that. So the purpose of this section is that we want to find the arc length of a curve. Like, for example, if you want to find the arc length from this point to that point. In fact, you are looking for the curve or the length of the arc from t equal to -1 to t equal to 3, right? Because this is 3, 0 means t equal to -1, and 3, 4 means t equal to 3. So you want to find the arc length of a parametric curve like this way from t equal to something to something else. Please note that um, only some special parametric curves you can solve x by y or solve y by x. But many others, and in fact most of them, we are not able to get such nice form. So we need a general formula to find the parametric curve that x and y given in this form, right? So here is the formula. So suppose we have a curve we call it C. It's defined by x is equal to f of t, and the y is g of t. Okay. And we want to find arc length when t equal to a to t equal to b. Okay. The idea is that we again want to break the whole curve into n pieces. Then for each piece, you connect the beginning and the end by a straight line segment. Then you have n pieces of line segments. Right? So these black line segments are an approximation of the red curve. So the idea is that we find the total length of these line segments. Then when we have more and more pieces, we get better and better approximation, right? So now let me find the general formula for one specific line segment. For example, for this specific line segment, if I call this point, right, by ti, so the x value is f of ti, and the y value is g of ti. Right? And for the end, because the next point will be plus delta t, right? Because if we cut to n pieces, then each piece we call delta t. Right? So next piece will be f of ti plus delta t, right? And the g of ti plus delta t. That's the x and y value, okay? So now the question is, what's the length between these 2 points? Okay. And we know that if we know the x and y value, of the 2 points, the length between these 2 points are square root of the difference in x value square plus difference in the y value square. So in this point will be this x value minus this x value square plus that x value minus, no, that y value minus that y value square. Okay, so we can get that f of ti plus delta t square minus f of ti, its difference in x square, plus g of ti plus delta t minus g of ti square. Right. So this is the line segment of this specific piece. Now we have n pieces, right? So if you add these n pieces, I go from 1 to n, then you will get these black line segments, the total length. Right? So the idea is that if we let n go to infinity, then we just need to do limit n go to infinity, right? Then we will get the exact arc length, because infinite many pieces means a perfect match. So the idea is that I want to rewrite limit sigma into integral, right? But unfortunately, we don't have delta t at the end, because we need, if you have integral, we need dt at the end. So we do some preparation, okay? So this guy is still equal to the limit sigma, right? But inside, I want to create delta t at the end. So I do the square root of, so I'm a little lazy, just parentheses square plus parentheses square. Please note these two parentheses are this and that, okay? Over delta t square, 10 times delta t square, right? So now the idea is that we move that delta t square out of the square root, this guy out, and we split the top. So it will be parentheses square over delta t square plus the other parentheses square over delta t square, right? Times, square roots of delta t square will be delta t, which is out of the square root, okay? So here, again, those parentheses are the whole big things, okay? Also, we know that this square can be moved out, this square can be moved out, okay? So it becomes to square root of a big parenthesis f of ti plus delta t minus f of ti over the bottom is delta t, then the whole thing square, plus g ti plus delta t minus g ti over delta t, the whole thing square, times delta t. Right. So this time, when n go to infinity, please note that this is n go to infinity. We know that delta t will go to 0, right? If you cut to infinite many pieces, delta t is almost 0. And this thing is nothing but the difference of f over the difference of t, right? So that's what? Actually, the slope of the tangent line of f at ti. And the slope we know is what? Is a derivative, right? So this is actually the derivative of f at ti, if you want to check the definition of the derivative, okay? So similarly, that guy is a derivative of g at ti. So you can rewrite that by the limit as n go to infinity, sigma inside the square roots, it becomes to f, the derivative at ti square, plus g, the derivative at ti square, times delta t. So finally, we get the result, because we know the limit sigma is in fact integral, right? So it's integral from t is from a to b. And inside the square root, every ti goes to general t. So it becomes to f prime t then square plus g prime t then square. Right? Finally, that delta t goes to dt. So that's how we get this formula. Okay. So if I ask you what's the formula of the curve f equal to ft and y equal to gt from a to b, this is a formula. All right. That you should remember. L is equal to this formula. It's the integral of square root of f prime square plus g prime square dt. Okay. So now let's see an example how to apply this formula. Okay. So the curve now defined by x equal to t square, y equal to t cubed. And we want to find the arc length between these 2 points. Please note that these 2 points are the x and the y value. They are not the t value. So first step is try to find what's the boundary of t. Okay. So we know 1, 1, 1, 1 is the x and the y value, which means x equal to 1 and y equal to 1. And we also know that x equal to t squared, right? Y equal to t cubed. So you want to solve the equation that t squared equal to 1 and t cubed equal to 1. There is only one solution, right? You get t must be equal to 1. Similarly, 4, 8. That means x equal to 4 and y equal to 8. And x is t squared, y equal to t cubed as definition. So you get t is equal to 2. So now we know that t runs from 1 to 2. Okay. Because in that formula, again, I write down the formula. L is integral from a to b square root of f prime t square plus g prime t square dt. So now you just need to find f and g. Right? So now f is a definition of x. So let me write down. So this guy is f of t. Right? That guy is g of t. So now you just need to plug inside everything, right? So a is 1, b is 2, square root. F is t squared, so f prime is 2t, right? The whole parentheses square. And g prime, so g is t cubed, so g prime is 3t squared, then square dt. Note, you need to put a parenthesis over this. Maybe I should write down okay? A parenthesis of this, parenthesis of this, okay? So now finally you get 1 to square root of 2t squared is 4t squared, and 3t squared square will be 9t to the fourth dt. And to find this integral, the TID9 will be helpful. So you just put it into a TID9. That integral of 4t squared plus 9t to the fourth with respect to t go from 1 to 2 if you want to find the numerical results. Okay. So diamond enter will give you 7.634. Okay. So it is equal to 7.634. Okay. So usually these integrals are very hard to use the fundamental theorem. So just use the TRD9 to find it. So that's how we apply this formula. So again, this is the important formula. Okay.